Hi, in this video on the Raspberry Pi with a binary counter controlled by the RPi2, I focus once again on timing. And last time I experimented with changing the time of 4 seconds to 20 seconds and back, and I found that the problem is not in here, but really in the counting process somehow. This timing is used for the time that it either counts forward or backwards, and 4 seconds to count any direction is quite short, no matter how fast the counter is. So I will change this back to 20. Oops. And this goes back to 20. It means I have to recompile. Which won't take long, of course, considering the length of it. And then I should focus on why it doesn't count as fast as it used to, and that I really have to do on the RPi side instead of the RPi2. I will have to change this to keep it in. Yes. So something in this code is preventing the counting from 1, 2, 3, 4, 5, 6, 7 fast enough that you can see with the 20 seconds that it really counts up, and with the reverse counting that it really counts down, because that is at this moment a big problem. So let's figure out how we do that. When looking at the complete code, so at the counter side and on the control side, there is not much timing going on. Here, of course, it is the timing between Gpio 18 and with Gpio 23, which are count, control and reverse count. And here on the counter side there is not much timing going on either. There's a sleep here and a sleep here. Apart from that, hardly anything. And this is repeated for input state 1 as well. So it is time to focus on another possible cause, and in this case I look at how the input from the switch and the signal for reverse actually are working. And here you see pin 33. Well, within C and C++, we don't look at the actual pins like we do in Python. However, Gpio 13 and Gpio 26 we do look at. And taking some distance from the code itself and looking at which pins are read, then it looks like here we read Gpio 13, as do we here. However, pin Gpio 26 is not read. So when we start look at the input state 1, it's actually exactly the same. Gpio 13 is read and not 26. So the question is now, how can we expect the signal to reverse if we don't even read that signal? So if we look at the thing at top, and you can see here when searching for Gpio 26, and the next one is right here. But this is all defining, and this is not running code or part of the algorithm. And then we see indeed it changes between these three. So this means that indeed the code for reverse isn't even implemented. Apart from that, the counter is very slow, but without reading it and reversing, you can't expect it to count down. So it is a very good thing to take some distance from what we have done so far and then see where Gpio 26 or reading from it can be implemented. And I think I should do it right here, because this is expected to be the reverse. However, it isn't. So what I can do is I keep reading this, but I add Gpio 26. Of course I can just copy it, and here of course there's a point because this uses input state, and I should not use input state here because it's an entirely different variable. So I should use reverse state. And then of course sc out to put the state actually on screen. But now we first have to define reverse state, and that we do right here somewhere. reading state of the switch, string old state, and here we say variable for reading the state of the reverse, and we say string reverse state. And I think it's a good idea to make it 0 for a start. So here we say show reverse state, and then the actual reading. So let's see what makes the difference, if it makes a difference. I'm very curious. Okay. So I will have to check that out for a moment. And with these two errors, looking in the code, and it turns out I made a slight mistake. So I have to go to line 72. Or do I? No, not here. However, here I made a mistake. This should not be a dash but an underscore. So let's try this once again. And as you can see, two errors caused by one typo. So let's see if this is going to work. But this looks like a very long time to me. Probably 20 seconds again, just like it says here. And let's say 5021. So let's see what the next one is. Actually it has gone to off and here's on again. So it is interesting to see what happens. Reverse state is 0, reverse state is 0, and of course, as it should be, off, on, off, and here's on, off. However, LED 2, as you can see here, LED 2 is off. So I should implement Gpio26 some further in the code. And here you can see that it switches to digit 4. So that means that this LED should have burned, and here's 5. So that means that somehow the second LED is not okay for some reason. And if all goes off, then there's definitely some sign that there's some physical not going okay. However, let's concentrate on Gpio26. Last time I measured this, it took more than a minute. So we don't wait for that, but we simply go on and see out reverse state, and here you put in Gpio 26 get val underscore Gpio reverse state. Actually, that line should be yes, and no, it's the other way around. Hold on. This is the way it should be. But also input state, I wonder if that should be reverse state. Because this is the reverse counting. So that's another point. Let's change that for a moment. We comment this out and we say here reverse state, and here reverse state as well. So let's see what happens now. Also you can see here that with proper ending by Ctrl+C, all LEDs are off. When I am not patient enough and I use the kill command, it just lets LEDs on, whichever one is burning at the time. Okay, that's a successful compilation. Let's start it. Let's see what's going on. I may have to change the algorithm if this quick fix turns out not to be a quick fix but a quick fault. That's one. And now if it goes to 4, it means that the second LED is indeed not quite correct. But for that to happen, this one should be off and this one, nothing is happening now. So if this one is turning on again, it is definitely clear that something is wrong with this LED. But we'll have to wait for that. It goes on, so there's nothing wrong. Quite a relief. It just doesn't burn as brightly. And testing takes a time. But it's a slow very slow counter still. So something is still not quite okay. Apart from the mix-up between input state and reverse state. Let's see now to the timing. This is quite remarkable. There is no time in it. With the last, if I scroll back. Oh, this is interesting. Yes. So reverse state is 1. I have to cut it off because as you can see, there is nowhere a change in the LED state except for here. And going back in time, here's one. And here's one. So that's 57. And it's 58, so that takes a minute, and in between virtually nothing happens. So this means that I have to review the entire code, and that will take time. And I think I have managed two things. First, to identify a problem that I totally forgot to implement the reverse, apart from defining it. And implementing this was totally left out. Then I had to add the string reverse state, and the next thing is that it turns out that whatever I meant for reverse state I mixed up with input state. So I think that is it for now. This I'll have is a result of the now mixed up state of the code. So thank you for watching, and next time I hope to find out and have find out to how the code had to be reversed and reviewed. So thank you, and to be continued.